Far beyond the familiar maps of galaxies, beyond clusters, beyond even the last faint threads of cosmic structure, there exists a time when the universe has grown old. Not in millions or billions, but in trillions of years. By this distant era, almost every star that once filled the night sky has already lived its life. Massive stars burned fast and died young. Some, like stars, faded into quiet white dwarfs. Even the smallest red dwarfs, the most patient of all, have finally exhausted their fuel. What remains is silence and darkness, stretching farther than any mind can truly grasp. And yet, not everything is gone. There is one last star, a faint, aging ember, still holding on to its nuclear fire deep within its core. A red dwarf among the last of its kind, sustained by the slow fusion of hydrogen into helium, a process so efficient it has outlived nearly all others. Around this final light, there is a planet, not unique in its origin, but extraordinary in its timing. Because this world is witnessing the final chapter of starlight itself. The expansion of the universe, driven by what we understand as dark energy, has stretched space so vastly that all other galaxies have disappeared beyond the cosmic horizon. From this planet, there are no distant galaxies, no glowing clusters, no evidence of a larger universe. Only one star in an otherwise endless void. To any observer here, the universe would seem small and profoundly empty. A single point of light, surrounded by perfect darkness. And yet, this lonely star still burns. Its energy still reaches outward, warming the surface of its final companion. A fragile balance between light and oblivion. This is the last refuge of warmth in a universe that is slowly forgetting how to shine. On this distant world, existence continues against all expectations. Not because the universe is kind, but because physics allows it. The star it orbits is small, a red dwarf with a mass far below that of stars like our sun. And yet, it endures, because smaller stars burn their fuel differently. They do not rush. They do not waste energy in violent bursts. Instead, they sustain a slow, steady fusion, mixing their hydrogen efficiently, allowing them to shine for trillions of years. This is why, in the far future, only red dwarfs remain. The planet, held close in orbit, receives just enough energy to maintain a delicate equilibrium. Not too hot, not too cold. A narrow region where matter can remain active, where chemistry continues, where complexity is still possible. But this is not the warmth of a young universe. The star's light is dim, shifted toward deeper reds and infrared wavelengths, invisible to human eyes, but still carrying energy. If you could stand here, you would not see a bright yellow sun. You would feel a gentle, constant warmth, without brilliance, without glare. The sky is unlike anything known before. There are no distant stars, no galaxies, no faint glimmers of light scattered across the darkness. Because over unimaginable spans of time, the expansion of space has carried everything else, beyond reach, beyond visibility. The observable universe has collapsed into a single system. One star, one planet, nothing else. Gravity still binds this pair together, a quiet dance that has persisted longer than all civilizations that ever could have existed. The planet turns slowly. Its orbit remains stable, predictable, unchanged. Here, time does not feel urgent. There are no cosmic events, no supernovae, no collisions lighting up the void. Only stillness. And yet, beneath this calm, the laws of physics continue their work. Energy flows, heat radiates, entropy increases. Even here, at the edge of time, nothing lasts forever. Even the most patient stars cannot burn forever. Inside this Untham red dwarf, nuclear fusion still continues, but not as it once did. Over trillions of years, hydrogen, the simplest element in the universe, has been steadily converted into helium. A quiet process, releasing energy, sustaining light. But now, that fuel is running low. Unlike massive stars, this one will not explode. There will be no supernova, no final burst of brilliance. Only a gradual, almost imperceptible decline. The core becomes denser, fusion slows. The outward pressure that once balanced gravity weakens, and slowly the star begins to change. Its light dims, not suddenly, but over spans of time so vast they defy human imagination. Each million years indistinguishable from the last. Each billion years only slightly darker. From the planet, this fading is almost impossible to notice in a single lifetime. But across deep time, the warmth decreases. The delicate balance that once allowed this world to remain active begins to shift. Temperatures fall, slowly. Chemical reactions lose energy. The environment becomes quieter, less dynamic. The star transitions from a red dwarf to something colder, dimmer. Eventually, nuclear fusion ceases entirely. What remains is a stellar remnant, a cooling object radiating away its remaining heat into the void. No longer a star, but a fading ember, drifting toward darkness. Astronomers call this final stage a black dwarf, a theoretical end state, not yet seen in our current universe because not enough time has passed. But here, in this distant future, it has become reality. And with it, the last true source of starlight disappears. On the planet, the change is absolute. There is no sunrise, no gradual glow on the horizon, only the slow realization that the light will never return. The final warmth fades, the last photons scatter into space, and the universe enters a deeper silence. Darkness is not an event. It does not arrive suddenly or announce itself. It simply remains after everything else is gone. The star, once the final source of warmth, has cooled beyond visibility. No fusion, no glow, no light. Only a dense, silent remnant releasing the last traces of stored heat into an expanding universe that no longer responds. On the planet, change has already taken hold. Without incoming energy, temperature drops, steadily, inevitably. Not to cold as we know it, but toward something deeper, toward equilibrium. In physics, heat always flows from warm to cold until there is no difference left. No gradients, no motion, no usable energy. This is entropy, reaching its final expression. The surface, once sustained by faint starlight, now radiates its remaining heat away into the void. Molecules slow, reactions cease, structures remain, but no longer change. Even the faint glow of the sky is gone, because there is nothing left to see. No stars beyond the horizon, no galaxies in the distance. The expansion of the universe has carried everything beyond reach, beyond interaction, beyond observation. This is not emptiness. It is completion. The laws of physics have not failed. They have simply finished their work. Energy has spread out as evenly as possible. Time continues, but without events to mark its passage. If you could exist here, in this Anthem era, you would not feel fear. There is no chaos left, no violence, no uncertainty. Only stillness, absolute and eternal. A universe at rest. And yet, even in this darkness, the story remains. Because everything that once existed, every star, every galaxy, every moment, led inevitably to this. Not an end, but a state where nothing more can change. This is the universe after the last light.